So yeah, today I'm going to present some of the results of this research initiative. It started actually late 2021, and it was a funding from OERD. And last year we received a direct funding from EGP to go a bit more progress. I'm gonna jump the abstract. I put this diagram here to try to summarize the approach and make it maybe a bit clearer. We tried to do a lot of things, and it was quite an ambitious initiative, I think, and it's still progress. So this is to simplify or to summarize the approach. Well, in the middle, we have the system we are working on. So we study sedimentary rocks. We choose reference rock for startup. And we study the interaction between the rock, the brine, and the CO2. We use basically we developed two different experimental setups. One of them is the reactor vessel. This is what I'm gonna talk about more today. And we try also to develop another experimental setup with a portfolio system. On top of that, you have all the green boxes. They're listed. They're a list of the different methodology we choose to try to characterize the system and how it evolves before and after experiment. In the dark green, it's potential application of the data we acquire. I'm not going to talk too much about that today, but still. And in the orange, I put two aspects that are important to take into consideration. We look at heterogeneity at different scale. So it's recommended at first. And also, our approach to monitor the changes is twofolded. One of them with the reactor vessel is to look at before and after picture, and the other approach with the bore flooding was to try to do in situ characterization of the changes within the system. Next. Try to also get take you a bit by the end through the approach. What I wanted to highlight is 3 points that are important for us, for the team. It was a joint effort. I should have mentioned that straight from the beginning. It's really a close knit collaboration between the GSC Quebec and several researchers, including Mathieu, Josué, and myself, as well as Nicolas. It is not Nicolas Pinet. And INRS, our partner, and the structure, the PGQ, the PGQ, or the PGQ structure is really really helpful in that way. So it's multidisciplinary. We have at least 5 experts and disciplinary involved. We work at different scales, so micro city scale, macro city, and macro scale, sorry. And we go up to decimetric scale when we look at larger size. And the last point, which is probably the most important, we choose and we wanted to use our own experimental setup, which was quite a challenge. And what it was developing as next, and also the image processing for the imaging tools. So both items are a lot of work. But we made that choice because we wanted to be able to, well, our workflow and to make it easily adaptable if we changed the focus of the research. So yeah. Next. So now for some of the results, or maybe I should call them what we managed to achieve in the time frame. The first methodology development, as I said, was to choose the reactor setup. So this is a reactor where our INRS partner, César Pasquier, is used to make carbonation experiments. And we use that reactor, we fill it with CO2. After a series of trials and errors, we managed to reach the condition, the pressure and temperature condition we wanted using liquid CO2. This was already something that we have to learn. And so basically, the rock and the brine are inside the reactor, and we put the condition reservoir condition we choose, and we leave the setup running for several days. On the right-hand side, you have the list of characterization we used. Some of them were on the rock sample before and after. Some of them, as I said before, we're using, no, I haven't said it, sorry. In some cases, we can do the characterization on the same sample, but sometimes we have to put the control sample versus the study sample. For example, I mean the thin section. We cannot obviously make a thin section and then the rock in the reactor at the same time. So next, this is what we managed to achieve. Once we had our experimental setup running, we made 5 tests actually for 5 different methodologies: 2 carbon, 2 dolomite, 2 limestone, and 1 sandstone. Before that, we prepare artificial brines based on the literature, and we studied the reaction at 140 degrees Celsius and 1,500 psi, and also for 7 days. On the right here, I put an example of a rock when it goes out after a 7-day reaction, and the sample strategy that we made. We try to document the reaction in the 2 different parts of the rock. The bottom part of the rock was within a brine saturated condition, and the other rock was free of brine. So these are some of the results. It's not really in order, but I will go first with what we were able to observe on the rock itself. On all of them, we did have evidence of reaction on the surface. In some cases, especially in the Indiana limestone, we could see enlarged pores at the surface. We also had, in some instance, precipitate that we were able to collect from the filters at the bottom of the tank, and also some traces of precipitate on the wall of the reactor. When we analyzed the brines before and after, we noticed a decrease in pH, so acidification basically, and a slight decrease in conductivity. So these 2 together definitely are consistent with a reaction between the rock and the system, and it's non-dissolution at first. When we used the micro-CT imaging, the before and after, it was not very conclusive for 3 of the lithology, but for the Indiana limestone and the Silurian dolomite, and this is the Indiana limestone, we could see that we have red spots where we have changes in the density before and after the test. So we know there is something going on. When we look at the petrography, I haven't put the same section in the graph here, but SEM images, we do have subtle changes, and maybe we suspect some minimal precipitation, but it's not very, it's really fine. So, right. So the conclusion here will be that we know our setup is working, and we were able in 7 days to create changes in the rocks, but it still needs some progress. The second development was the geophysical part of the study is under development, even if it's now is to have a setup working using a core flooding system that was adapted and redesigned to put electric and acoustic sensors within it. The big issue here is that modifying the classic corridor setup was tricky because there was a lot of problem with the tightness of the system when we were reaching 1,500 psi. So I think it's still an achievement because it's a setup that it does exist now, but it's still under development. So to conclude, yeah, I think the message to bring home is that it was a big challenge to develop our own setups, and this is an achievement in itself to have 2 different types of setup working at the same place with the same research team. We know that we are able to choose different. Some of the analyses we tested were helpful to notice changes in the system. Some of them we want to retain. And the good news is it was sufficiently interesting for Christine Viva to take part of the initiative we've done under the EGP cycle and make a bigger effort under the new geoenergy program. So this is the ongoing project now under the facility. Thank you.